Hello student, this is Satish Nikam and welcome back to our channel. In this lecture, we are going to discuss about the hardware structure of the input and output ports of 8051 microcontroller. As we know that 8051 microcontroller is a very popular 8-bit microcontroller that is used in embedded systems. As we have discussed in the previous lecture that 8051 microcontroller has 4 I/O ports, named port 0, port 1, port 2 and port 3, and each port consists of 8 pins numbered from 0 to 7. Means port 0 is having numbers from 0 to 7, port 1 is having numbers from 0 to 7, port 2 is having numbers from 0 to 7, and also port 3 is having numbers from 0 to 7. These ports are used to interface with other devices and peripherals such as keyboard, sensors, displays and communication devices. Each I/O pin of 8051 microcontroller can be configured as an input pin and output pin. When an I/O pin is configured as an input pin, it can be used to read the state of an external device. And when the I/O pin is configured as an output pin, it can be used to control the state of an external device. By understanding the hardware structure of a pin, we can understand how to configure these pins as an input pin and output pin. Let us consider the example of pin for port 1. Here P1.X means this structure is for port 1 and X indicates any pin of the port 1. This figure shows the hardware structure of a single pin of port 1. This type of structure is available for all the pins of port 1 separately. If we understand the function of one pin, we can easily understand the function of all the pins of the same port. In this, pin is connected. Here this pin is connected to the internal CPU bus through the hardware. Let us discuss the hardware in detail. The first component which is very important, and that is D flip-flop, or we can also call it as a latch, which stores the value of the pin. Whatever may be the data which we got, it is get stored on this particular flip-flop by write to latch P is equal to 1. When this pin becomes 1, the data which is available gets stored on the latch. There are two tri-state buffers, that is TB1 and TB2. This TB1 is get controlled by read pin. When this read pin signal is equal to 1, data present on the pin is get stored into the flip-flop. This we will discuss in detail when the actual read operation we will discuss for the pin. TB2 is controlled by read latch. When this read latch pin is equal to 1, whatever may be the data which is present on the internal latch, it is get available on the CPU bus. We are having here one transistor M1. For that we are having here gate pin. When this gate pin is equal to 0, the transistor will act as an open switch. This particular pin is connected to the VCC through the load resistor. And when this gate pin is equal to 1, this transistor will act as a closed switch and the pin is connected to the ground. This load resistor is another hardware. This is the pull-up resistor. When the pin is not connected to ground through the transistor, it maintains the voltage VCC on the pin. Let us now see how 1 is sent on the port pin. When CPU send 1 on the internal bus, but it is applied on the D input of the D flip-flop, and this one it is get stored in the flip-flop which is available on the Q pin. And as we know that for a flip-flop, if Q is equal to 1, Q bar is 0. So Q bar becomes 0 here, which is applied on the gate pin of the transistor, which makes the transistor off and will act as an open switch. Because of that, VCC voltage it is connected to the pin which is available on the pin, and so the output becomes 1. Here one important thing that we have to remember: when 8051 microcontroller CPU sends 1 to the peripheral, current flows from VCC to the peripheral through the pull-up resistor, not from the CPU to the pin. which saves the 8051 from loading and heating effect. Let us now see how 0 is sent on the pin. When the CPU sends 0, which is gets stored into the D flip-flop, and we got the 0 on the Q pin here. As Q is equal to 0, we got Q bar is equal to 1, which is applied on the gate pin of the transistor. And because of that, the transistor will act as a closed switch and the pin is get connected to the ground. So we got 0 on the port pin here. This way the CPU can send the data 0 on the particular pin. Now we are going to discuss how microcontroller reads the data from the pin. When we have to use the pin as an input pin, first write 1 to the pin through the D flip-flop and the transistor. This is possible by using a simple instruction move P1, #00H. Because of this, all the pins of the port 1 will get 1, and this one it is get stored in the flip-flop, and because of that Q bar becomes 0. This 0 is available on gate pin of the transistor, which makes the transistor as an open switch, and the data present on the pin is available on the tri-state buffer 1. Now controller will execute a simple instruction move A, P1. If we consider that the data given by the external peripheral is 1, this one is available on tri-state buffer 1. When a read pin signal is given by the CPU to the pin, data which is available on TB1 input is available at the internal CPU bus here, and also it is available on D input of the flip-flop. This way the signal 1 available on the pin can be read by the CPU. Same way, controller can read the low data available on the pin. First, CPU will send 1 on the D pin of the flip-flop. Because of that, we got 1 on the Q pin of the flip-flop, and because of that Q bar becomes 0. And this 0 is available on gate pin of the transistor, which makes the transistor open switch, and because of that the data which is available on the pin is available on TB1. Now controller will execute a simple instruction move A, P1. If we consider that the data given by the external peripheral is 0, this 0 is available on tri-state buffer 1. When a read signal is given by the CPU, this data is available on the internal CPU bus as well as input of D flip-flop. This way, the low signal available on the pin can be read. Conclusion is that all the pins of 8051 microcontroller work as an output pin. All ports work as an output ports. CPU can send the data on the pin directly, or CPU can send the data on the port directly. But if you want to use the pin as an input pin first, you have to send one on that particular pin. That pin will get defined as an input pin. Then the CPU can read the data from that particular pin. Same way, if you want to use a complete port as an input port, you have to send one on all pins of the port. This can be done by using a simple instruction move port, #0FFH, and the port will act as an input port. This is all about the hardware structure of 8051 microcontroller. In next lecture, we will discuss about the program counter, data pointer, A and B registers of 8051 microcontroller. Thank you for watching. See you in the next video.